Hi, welcome to the practice questions on being able to solve simultaneous quadratic equations using the substitution method. What I'd like you to do now is to pause the video and have a go at the two questions. There's one on this page, one on the next page. When you're then happy with your answers, then restart the video and have a look at the model answers. So pause the video now, have a go at questions 1 and remember question 2 on the next page. Hi. Welcome back. Let's now start to go through these together. Question 1 then. The first thing you notice about this is that there is the y squared there in one of those equations. This means we've got a quadratic, we have to use the substitution method to be able to solve it. Now the first thing you do, always, is to rearrange one of the equations so that you've got it in terms of either x or y. This one's already been done for us. So if we have a look at the first equation here, y equals 3x plus 1, we've already got y as the subject. So what we can do is we can start off with this one and we can then substitute an expression for y into the second equation. So we've got y squared here, but y is going to be 3x plus 1. So the first thing we're going to do is sort out this y squared. So if I go over here and write y squared, now y squared is going to equal now 3x plus 1 squared. So we have to multiply out these double brackets here. So we'll do that first. So 3x plus 1 multiplied by 3x plus 1. Let's do that together. So 3x times 3x is 9x squared. 3x times 1 is just 3x. Then 1 times 3x is 3x. And 1 times 1 is just 1. If we group these two here together, we get 9x squared plus 6x plus 1. This now takes the place of this term here. So we get 3x plus 9x squared plus 6x plus 1. We can obviously group together these terms here. So we've got 9x squared plus 6x plus 1. Plus 9x plus 1. And that is equal to 5. Now, to solve this quadratic, we need to have it equal to 0. So all I do now is take the 5 over, so 9x squared plus 9x, take the 5 away from the 1, and you're left with negative 4. That now equals 0. We've now got a quadratic to be able to solve. So, let's solve this by factorising. 9 times minus 4 gives us minus 36. We're now looking for two numbers that multiply to give us negative 36 and add to give 9. So you should be able to see that those two numbers are going to be minus 3 and 12. Minus 3 times 12 gives us the negative, and minus 3 add 12 takes us to positive 9. Split the middle term into the minus 3 and the 12. Let's make sure we put the minus 3 first so it factorises with the 9. So we get 9x squared minus 3x plus 12x minus 4 equals 0. Factorise in pairs. So let's factorise this bit first. What occurs in both? Well, 3x occurs in both. Open brackets. 3x times 3x gives 9x squared, and 3x times minus 1 gives us minus 3x. Factorise the second pair. What occurs in both? Well, it's 4. So we write here plus 4. Open brackets. 4 times 3x gives us 12x. and 4 times minus 1 gives us 4. That's equal to 0. Then we write whatever's outside the brackets in one set and whatever's inside the brackets in the other set. And now we can solve these. So obviously 3x minus 1 equals 0. So if we take the minus 1 over, 3x is going to equal 1. So x will equal a third. But in this case, 3x, if we take the 4 over, 3x equals minus 4. Divide minus 4 by 3. X is going to equal minus 4 over 3. We've now got our x values, but of course this is a simultaneous equation, so we've got to find our y values. But this is pretty straightforward because all we're doing here is subbing or substituting our x value back into the easiest equation, which is this first one. So if we put x back in place of x here, we get y equals 3 times a third. 3 times a third is 1, plus 1 is 2. So x equals a third, and y is going to equal 2. Then for the second one, if we put back in minus 4 thirds, it's a little bit harder, but if I'll show you up here, if I do 3 times minus 4 thirds, well, 3 times minus 4 is minus 12. Minus 12 divided by 3 is minus 4. But then I've got to add the 1. So minus 4 add 1 gives me minus 3. So y equals minus 3. So when x equals a third, y equals 2. When x equals minus 4 thirds, y equals minus 3. Okay. Question 2 then now. Exactly the same type of thing here. We've got no rearranging to do because we've already got y as the subject. So we've got to replace now 2x plus 2 in place of y here. Again, we've got to multiply out the brackets. So we've got 2x plus 2, which we're putting in place of the y here, and we have to square it, which is 2x plus 2 times 2x plus 2. We'll multiply this out. We get 4x squared plus 4x plus another 4x plus 4. If we then group the 4x's together, we get 4x squared plus 8x plus 4. We now replace this into here. So this second equation becomes 4x squared plus another 4x squared plus 8x plus 4 equals 74. Now we want to make this into a quadratic, so we group the x squareds together, which gives us 8x squared plus 8x, but let's now take the 74 over and take it away, which is minus 70 equals 0. Now if we divide this through by 2 to give us 4x squared plus 4x minus 35 equals 0, it might make it a bit easier. Let's times these two together. 4 times minus 35 gives us minus 140. We're now looking for two numbers that multiply to give us negative 140 and add to give us 4. Well, that's going to be minus 10 and 14. Minus 10 times 14 gives us a negative, and minus 10 add 14 gives us 4. We're now going to split the middle term into these two numbers. So we get 4x squared. We need to have the negative 10 first, plus 14x minus 35 equals 0. See, I put the 10 there because it factorizes better with the 4. They're both even numbers, and the 14 here will factorize with the 35 because 7 goes into both of them. So if I if I split these down the middle, then what occurs in both? Well, we've got 2x occurring in both of these. So we write 2x outside the brackets. 2x times 2x gives us 4x squared, and 2x minus 5 gives us minus 10x. 7 occurs in both, and then 7 times 2x, 7 times 5 is minus 35. Check that you've got the same terms inside the brackets. And then whatever occurs outside goes in one set, so 2x plus 7, and in the other set, 2x minus 5. If we solve those, first one, 2x is going to equal minus 7, so x is going to equal minus 7 over 2. And for the other one, x is going to equal, if we take the 5 over, it becomes positive, so x is going to equal 5 over 2. Then we need our y values, so we have to substitute this value for x back into the first equation. So I'm just going to do this over here. So if we do y is going to equal, let's put this one in first, 2 times minus 7 over 2. Well, that's going to give you minus 14 over 2, which is minus 7, plus 2 is going to give us minus 5. And for the second one, we're putting 5 over 2 in, or 2.5. Well, 2 times 5 over 2, or 2 times 2.5 is 5, plus 2 gives us 7. So if we finish this off, just write the y's next to it. Y is going to equal negative 5 when x equals negative 7 over 2, and y is going to equal 7 when x equals 5 over 2.